All right. Hello, hello, hello. Hope you had a great evening, great day. If it was a weekend, hope you had a great weekend. I got my coffee cup here. I'm here at the school. So let's keep talking about applications. We're gonna figure out how to do some simple mixture and some simple interest problems today. Okay. So let's get going on that. I should always set my pen before I start talking with you guys, but I forget. And then I get in a hurry. All right, here we go. All right, we're going to start with mixture problems, okay? And the first thing you have to understand is what they mean when they say find the pure amount, okay? You might be talking about a solution, an acid solution if you're in the sciences, just anything that you're mixing with water, maybe an alcohol solution. But to find the pure amount, you're going to take the number of liters or the volume of whatever it is, your base, whatever that is, and you're going to multiply it by the rate. This would say like a 14% solution. 14% solution, all right? You want to make sure that your rate is written as a decimal. So this would be like 0.14, okay? All right? That is like the key to being successful. If you multiply it by 14, you're going to be way off, okay? So let's make sure we understand how to write a rate as a decimal. 35%, this is part out of whole would be 35 over 100, which is equal to 0.35, all right, or 35%. 7% would be 0.07. 2.5% would be 0.025. So make sure that you know how to write your percentage rate as a decimal, okay? Okay, let's move along and let's do some of this stuff. Okay. Finding the pure amount. If a chemist has 40 liters of a 35% acid solution, what is the pure amount? So I'm going to go to my highlighter here real quick. All right, so we have 40 liters. This is your base, okay? You have 40 liters. You're going to identify your base because it's going to be liters or milliliters or ounces, you know, some measured amount. And then your rate is the 35% acid solution. Chemist has 40 liters of a 35% acid solution. What is the pure amount of acid in that? All you do is take base times rate. And you get 14 liters of pure acid. That means that you have 26 liters of non-acid, all right? Some kind of filler liquid. Maybe it's water. Maybe it's some other kind of hydrogen peroxide. I don't know. You don't want to explode anything, but all right? So you try B real quick. Hit pause and come back and try B real quick. All right, welcome back. How much pure alcohol is in 125 milliliters of a 14% solution? Okay, so my base has to be a quantity or an amount, right? So my base is 125 milliliters. My rate is going to be a percentage, right? So the only thing I have in here is that 14%. So my rate is 14%, 0.14. My pure amount has to be my base times my rate. So I'm going to get 125 milliliters. Ooh, that looks bad. Times 0.14. And when you hammer that out, you get, 17.5 milliliters of, that's alcohol. 17.5 milliliters of alcohol, which means how much is non-alcohol? Well, you're going to have to take 125 minus 17.5, or 107.5 milliliters of non-alcohol. Okay? So make sure you pay attention to what the question is asking you to find. All right. We need to be able to use this idea of base times rate, finding the pure amount, so that we can take a weighted average and do mixture problems. You can identify mixture problems because you have two or more solutions of a different percentage rate that you're combining together. Two or more solutions of a different percentage rate. Okay? You're going to combine them or add them together to come up with a single solution. Okay? You're going to take a 10% solution and you're going to mix it with an amount of 15% solution so that you get some kind of solution that's like 12.5%. All right? And we want that single solution to have a specified or a certain percentage rate. Okay? Keep in mind that the rate has to be between the two other rates. All right? The good news about this is like the equation, you can set the equation up the same way every single time. It always looks like the rate or the percent times the amount of the first solution plus the percent times the amount of the second solution has to equal the new percent times the sum of those two amounts. Okay, because you're adding them together. So let's see what it looks like. This one I've done for you, so let's just talk through it. All right, a chemist needs to mix 20 liters of a 40% acid solution with some unknown amount of a 70% solution to make a solution that has a 50% acid ratio, or acid solution. Find the amount of 70% solution needed. What am I looking for? I'm looking for the number of liters of a 70% solution. Find the liters of the 70% solution. All right? Now, assign your variable. Well, X is going to equal the number of liters of the 70% solution. All right? Remember to always write your rate or your percentage in terms of a decimal. So I have, here's the 70%. And I wrote it down here as 0.70 because I wrote it as a decimal, all right? 0.70 times X, because that's what I'm looking for, all right? Plus 0.40 times 20. Why times 20? Because he has 20 liters of this 40% solution, all right? And that has to equal the new rate times the sum of these two, the amounts of these two solutions, all right? X is what we don't know. We know that we have 20 liters of the 40% solution. So now we just solve a simple linear equation. I'm going to distribute over here. So I get 0.70x plus 8 equals 0.50x plus 10. I'm going to subtract 0.5x from both sides, and I get 0.20x plus 8 equals 10. Then I'm going to subtract 8 from both sides, and I get 0.20x equals 20, x equals 10. And then you just check it. This is 10 liters. 10 liters. Don't forget to put your units down, all right? Okay, here we go. Let's try this one together. A metal is 40% copper. how many kilograms of this metal, so there's what I'm looking for, how many kilograms. I'm looking for the amount of a 40% copper metal with, must be mixed with 80 grams of a metal that's 70% copper to get a metal that's 50% copper, all right? A lot of words, but try and just focus on the values, okay? All right, a metal is 40% copper. We're looking for how much of this metal. How much of this metal? So I'm looking for amount of 40% copper. Okay? So X is equal to that metal. I'm going to write an equation. I'm going to have 40%. I have to write that as a decimal. So I have 0.40x plus. Now I have a 70% copper. So that's 0.70. And then I got to multiply that by 80 kilograms times 80 has to equal 50%, 0.5 times x plus 80. Okay? Because when I add these two together, these two amounts together, I need to come up with a 50% solution, or a 50% metal. So now I'm going to solve for the variable. I'm going to do it some multiplying. I got 4.40x plus plus 56. Sorry, that's not right. Yep, plus 56. That looks crummy. Equals 0.5x plus 0.5 times 80 is 40. That's like half. All right. I'm going to move my x's together. So I'm just going to go to the left with them and subtract 0.5x. So I get negative 0.10x is equal to, and then I'm going to subtract 56 equals negative 16. So x is going to equal 160 kilograms. And then of the 40% copper, all right? And then we just check it. We have to make sure that 0.4 times 160 plus 0.7 times 80 has to equal 0.5 times 160 plus 80. And 0.4 times 160 is 64. That we know is 56. All right. And then half of 240, 160 plus 80 is 240. And then half of that is 120. Okay, I'm going to scooch you on over here. Sorry. And I'm going to add 64 and 56. And I get 120. So it worked. 120 equals 120. And it checked. Okay? All right, now we're going to switch to interest earned. All right? Same kind of thing, only we're labeling them just a little bit different. Remember that interest earned is equal to a principal. This could be like your base or your principal times rate. Principal is the amount that you put into an account or a money market fund or some kind of investment account. Rate is the percentage of interest that is being paid. Always make this as a decimal, okay? Make sure you understand how to do this. If you don't know how to do this, please come see me. Please, 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 please. All right. If $1,300 is invested at 7% simple interest for 1 year, how much interest is earned? So principal is the amount that you deposit. That's $1,300. That's what was deposited, $1,300. Okay? The rate is 7%. Always express it as a decimal. So your interest earned is equal to principal times rate. Just plug it in. 1,300 times 0.07 and you get $91. That's the amount of interest you would earn in a year if you invested $1,300 at 7%. You try B and we'll come back and see if you got it right. All right, welcome back. Find the amount of interest earned if $5,000, that's the principal, is invested at 4% interest. All right, so I'm going to get my pen. All right, my principal amount is $5,000. My rate is 4%, so that's 0.04. So now I'm going to multiply those together. Interest earned is principal times rate. And I get 5,000 times 0.04, and I get $200. That's how much I earn in a year. Simple interest. All right. Now, let's say we have two accounts and we want to try and invest in two different amounts. This is like a mixture problem, right? Only we're working with interest. You received an inheritance from Great-Grandma June. You plan to invest in two accounts. One plan pays 6%, the other pays 7%. If you invest $2,000 more in the 7% than the 6%, how much would you invest in each account to earn a total of $790? Lots of words, but not a difficult problem. What we're asked to do is how much should you invest in each account? That's what we're asked to do, right? So we're going to identify the amount in each account, assign a variable. Well, if we could figure out how much to put in the 6% account, right? Whoops. If we could figure out how much to put in the 6% account, then we know that we want to put $2,000 more in the 7% account, all right? So that's why we're going to let X equal the amount in the 6% account. Then X plus 2,000 is the amount in the 7% account. Now this just becomes rate times amount plus rate times amount equals rate times the sum of the amounts. It just becomes a matter of plugging into this formula. This formula is very important. You want to learn this, all right? So I have 6%, 0.06, I'm going to do my highlighter here, 0.06 times X plus 0.07 times X plus 2,000. Why? Because I know from what I'm told that you're going to invest $2,000 more in that account, all right? And then when it's all said and done, they've already figured out this value right here needs to be $790. They give you this. You don't have to calculate this anymore, all right? We're going to distribute, all right? Don't forget to do this one, you guys. Don't forget to do that one. I still have people who are struggling with distribution. We need to learn that, all right? I'm going to combine my x's. I get 13x, 0.13x plus 140 equals 790. I'm going to subtract 140 from both sides, and then I'm going to divide by 0.13, and I get $5,000 in the 6% account. All right, why? Because we defined X to be that. And then I'm going to add $2,000 to it, or $7,000 to go in the 7% account. All right. Let's try this one. Okay, I've helped set it up for you. With income earned from selling a patent, you will invest in two accounts paying 5% and 8% interest. You plan to invest $3,000 more than twice the amount in the 8% plan. You're going to be risky, all right? You're going to put more in that 8% plan. How much should be invested in the 5% account to make $1,710 in interest? All right, so we're going to find the amount in the 5% account. Okay, so X is the amount in the 5% account. Now to find the amount in the 8% account, we know that it has to be $3,000 more than, so that's a plus, twice the amount. Okay? So $3,000 plus twice X. Again, now we're at the point where we can distribute. All right? So I have 0.05X plus 0.16X plus 240 plus 240 equals 1710. That looks really crummy. All right, so I have 0.21X plus 240 equals 1710. And then I have 0.21X is equal to 1470. So I got to divide by 0.21. So that means I need to put in $7,000 in the 5% account, and then 2X plus 3,000, $17,000 in the 8% account. All right, coming up on the last slide. There it is. Woohoo! Okay, I'll see you tomorrow. We're going to 15, 17, and 18. We won't set up the table like they do. We're just going to do it like we did in the notes. Remember, this is your key phrase right here. This is the thing you want to refer back to. Okay? So I'll see you tomorrow. Bye.